All right. Hello, everyone. Thank you so much for joining this talk on machine learning for .NET developers. This is an introductory talk, so you don't need any prior knowledge. And if you're curious about machine learning, or if you started doing something but found some terminology, some concepts confusing, this is a great point to start. And hopefully after this talk you will be ready to jumpstart in your machine learning adventure. So first, very quickly about me. My name is Olia Gavrysh, and I'm a program manager at Microsoft working on .NET team. Right now, I'm focusing on Windows Desktop, .NET Core, and .NET 5. And before, I was working on machine learning framework for .NET called ML.NET. And I also have a background in machine learning, artificial intelligence, and mathematics, so that's why I'm doing this talk today. You can always reach me on Twitter if you have any questions, and I will try to answer questions on Slack and in WebEx. So machine learning, it became extremely popular over the last decade, right? Everybody heard about it. Everybody wanted to try it, to get related to that. And regarding to how developers should use machine learning these days, there are two different opinions. The huge interest brought to life lots of machine learning frameworks, right? So many things are already implemented and available for you, like out of the box solution. And when people are thinking that machine learning should be easy, in 2020, you don't need to get a data science degree. You should just take existing framework and get the output, just plug it in your application and use it. Right? But there is another group of people that think that when you start doing machine learning without knowing mathematics that stands behind it, that's what you might end up doing. Well, my personal opinion is that the same balance between the two is the best solution because, of course, yeah, you don't need to multiply matrices and reinvent machine learning algorithms, right? We want to leverage what already exists. But it's very beneficial to know how machine learning works so you can use it in the most efficient way. And that is why today we will do two things. First, we will do a machine learning crash course where I explain the basic concepts, terminology, how machine learning works, like minimum knowledge that you need to move further. And then we will create a machine learning model with .NET. So let's start with machine learning crash course. Artificial intelligence and machine learning are surrounding us in everyday life, right? When you're unlocking your device with the face recognition or fingerprint, when you're using your favorite virtual assistant, when you're getting recommended products or movies based on what you already bought or have seen. And even when your license plate got recognized by the traffic camera or by the toll bridge, that all is available thanks to AI. The last one is less fun because usually you receive a bill at the end. But how can you use machine learning when you're a developer? How can you benefit from ML in your applications? Well, there's so many different ways. And for example, you can predict a sentiment of a review. If you have a web store and your customers post review, you want to categorize them, which are positive, which are negative, how to sort them. You can use machine learning for that. You can also detect a fraud transaction or a defect item. You can classify certain forms of complaints from your users. You can aggregate them and label them to, for example, complaints, improvements, refund request, and so on. You can identify if some of your customers are likely to cancel a subscription, and then you can advertise certain promotions to them. You can recognize handwritten text and handwritten digits. Machine learning can advise you to optimally stock right amounts of products for the next months, and so on. Well, what is common for all those tasks? They are difficult or impossible to solve using traditional programming, right? Because, for example, how would you program to define if this picture is a face or it's not a face? It's virtually impossible. Of course, you can try to see how many pixels of certain color there is, but there are different skin colors, there are different angles, close-ups. It's impossible to do via procedural approach. What machine learning does, it creates a function, and in machine learning world, we call it model, and this function consumes data with known answers. So for example, we have plenty of pictures, and for some pictures, we know that this picture is a face, and for others, we know these pictures, they're not a face. And we feed in this data into our model, our function, and the model changes itself. It adjusts coefficients, what we call it learns from those known answers, and it shapes the function that way that in future, when we want to send the picture and ask, is this a face or not a face, it will be able to give us a result. And we will dive deeper into that, but for now, you should know that machine learning creates a model using data. Okay, so how do you get that model if you want to use machine learning in your applications? Well, there are two ways. You can use existing solutions. It's a pre-built model that are already trained for you and available through a variety of different services. And if those solutions work for you, that is great. Actually, let me jump to the demo and show you one solution that we have in Azure Cognitive Services. One second, I will open. So I'm opening my Azure portal. Let me try it. Okay, so here you can create a resource, and there is a tab AI and machine learning. And here you can see plenty of different options for machine learning already ready for you for consumption. So machine learning, web app, bot, computer vision, face, text analytic, Bing search, and so on. You can create the resource. It takes a little time, so I already created computer vision. And we have a console with APIs where you can play around, you can see the syntax, you can send APIs, receive feedback. So that's a great start if you want to get familiar with APIs. Let's take a look at detect object. So detect object API, it takes as a parameter URL, and it will detect objects on that image and try to point draw a rectangle where those objects are and describe them. So what I decided, I don't know if you can see, but I decided to turn around and take a picture of this couch and send it to AI. Let me first show you the picture. I have. Okay, this is the picture that I'm going to send to the API. So I'm just going to replace this link to my picture and click send. This is how the API will look like. Request, I got response. Let's take a look. Perfect. It says it is sofa bed and is also couch with given probability. It's something for sitting, and it even draws a rectangle around that couch. Great. So I decided to not stop on that and go further. And let's try another API. Let's go to describe image. This is the describe image API. So I will send exactly the same picture here. All right, so this is how the request looks like. And this is the response. So we have text, a living room with a blue chair. Well, and the confidence, 96%. Oh, I would say that's pretty impressive, despite the fact that my couch got demoted to chair, but in fairness, that is the smallest couch I was able to find. So according to American standards, it's not a couch, barely a chair, more like uncomfortable stool. So I decided to play with that a little more, and then I asked my boyfriend to sit on the couch. So I got this picture, and I'm going to send this picture to AI and see what that's going to describe. All right, let's see. A person sitting on a chair in a room. Wow, pretty impressive, right? All right, so let's go to our slides. That was a pre-built AI. And if it works for you, that's amazing. I would recommend you use it. It's usually paid services, but you will get a very good value for your money because data scientists spend a lot of time and effort and skills to create those services for you. But there are cases when pre-built services don't work. And let me show you an example. For example, let's say we have a store that sells vacuum cleaners. And we receive feedbacks from our users, and we want to use machine learning to classify if the feedback was positive or negative to label them. And we're going to use sentiment analysis. We're going to send the review into the API and get the response. What is the probability that that is a possible positive review? So this vacuum cleaner sucks. This is a great vacuum cleaner. We get response 96% positive. Awesome. But when we send the next review, this vacuum cleaner sucks so much dirt, the probability that it's positive will be only 9%. It will be marked as a negative. And that is expected because usually when we say sucks about the product, it doesn't mean great, right? So in this case, the pre-built solutions would not work for you, and you need to come up with the custom AI. Custom AI is when you create the model yourself or you build this model on your personal data. And there are many solutions for custom AI as well. And today we will take a look at ML.NET framework that allows you to build custom machine learning. So when can you build custom ML? When you have a repetitive decision or process, when your solution lacks an explicit definition, because otherwise you would just use normal approach, and when you have a lot of historic data. Data is very important. The more data you have and the better your data is, the better machine learning prediction you will receive. Because ML algorithms existed 60 years ago, right? But back then, computers were not powerful enough to accumulate and process enough data. And just in the latest 20 years, and especially in the last decade, computers became extremely powerful, and that's when machine learning just took off. So let's get familiar with some terms and concepts before we start doing some machine learning. Machine learning, there are different types of machine learning, 3 of them. First is supervised learning, or learning with a tutor. In this case, we have the historic data that we're going to train our model on, and this data has known answers. So for example, we have sales of houses, and we know how much we sold each house for the last year. For each house with the number of bedrooms, square footage, address, features, we know what was the price. And when we train our machine learning on this data, we every time tell the model what was the right answer, and that is the role of the teacher who is correcting the student and points to the mistakes, tells if the answer was right or wrong during the training. There's also another type of machine learning called unsupervised learning. In this case, our data does not have answers. So in this case, we just need to reorganize data, find some structure, present it in a more meaningful way for future consumption. And there is also reinforcement learning. In reinforcement learning, machine learning reacts to the environment. So it gets constant feedback from the outside. And the great example here would be a computer game where we do some actions and we get reward or punishment for those actions. And all that is happening in the real life, right? We will go to the left, we will eat a berry, our house will improve, we get the positive feedback from the environment. Then we go to the right and somebody will eat us, so our house will get destroyed, we'll get negative feedback from the environment. That is how we learned where we should go and where we should not go. Okay, there are also different machine learning tasks. And the most popular task, the most widely used, are this one. First one is classification. That's when we're trying to answer to the question, is this A or B? Or A, B, or C? For example, when we are trying to classify the sentiment, is it a positive or negative review? Or something, is it true or false? When we have two options, it's a binary classification. When we have more than two options, for example, the traffic light, green, yellow, blue, is it a dog, a cat, or a hamster, and so on, that would be multi-class classification. The second ML task is called regression. And in this case, we are trying to answer the question, how much or how many? So we are looking for a value. And great examples would be, how much will the house cost? Or what will be the temperature? Or how many sales will I make? How much time do I need to wait? What is the price? What is the delay? And so on. And the third very popular machine learning task is clustering. In this case, we are trying to organize our data in certain clusters. So we want to find the similarities within the data set and divide it in sub-data sets. Great example here would be, we have a variety of users and we want to cluster them and then do targeted advertisement for those groups of users. So for example, for one group, we will show the advertisement of sweets, and for another group, we will show the advertisement of liquor. Another example can be, we have the website with news and we are getting new articles on all different topics. We don't know which topics we will get every new day. So we're just running clustering to organize them in certain ways. So articles regarding sports are in one tab, articles regarding politics is in another. The difference between clustering and classification is that for classification, we know our groups. And when we are training the algorithm, we know what are the right answers for the historic data. In the case of clustering, we don't know that there is a group white and yellow, or there's a group dog, cat, hamster. We just know that here's our data and we want to structure it in the more optimal way for the further insights. So as we discussed previously with supervised learning and unsupervised learning, now you might guess that classification and regression is a case tasks for supervised learning. And clustering is the example of unsupervised learning. Here we don't know the right answers ahead. Right, now how machine learning works. I like to learn by jokes. So I'll read this joke for you. It's a technical interview and an interviewer is asking, what is your biggest strength? And the person who takes interview, or me, is answering, I'm an expert in machine learning. Interviewing us asking, okay, what is 9 plus 10? It's 3. Not even close, it's 19. It's 16. Ron, it's still 19. It's 18. No, it's still 19. It's 19. You're hired. Okay, now why this is funny? Because when my dad saw that joke, he was like, what? What a nonsense. Well, it is funny because that is exactly how machine learning learns, right? We're asking our algorithm a question, like what is 9 plus 10? And first it comes up with any answer, like 3. And we're telling, okay, that's not 3, this is 19. So machine learning calculates the difference. It realizes, okay, I'm way off. I need to retrain myself. It adjusts coefficients inside, and it gives me another answer. It's 16. And okay, it's still 19. Okay, algorithm sees that the difference is less, so now we're in the right direction. It's better, but it's not yet satisfactory, so I will keep learning. And it learns itself until the answer is good. Same thing in math language. The task of machine learning is to build a prediction, white hat, which is a function of our incoming data, x, and we want to build the prediction the way that the difference between our prediction and the real answers is minimal. So usually we compose the cost function, and that function shows us how our prediction is far from the reality. And here you can see we are using the model absolute value, but it can be any norm. It can be root mean square, and etc. Now, same what I just said, but with pictures. So let's say we have some data, and we're starting with approximating this data with a function. And we'll start with the most trivial one. We'll draw a line ax plus b. And then we will calculate how far is our prediction from the data we are training on. Okay, here we can see that it's pretty far. So we want to come up with something else. All right, this function, how far are we? Okay, it's better, but it's still not good. Then third attempt. Okay, here we can see that we described the data quite well. That would be our answer. Now, when we are building approximation, our models, there are a few cases that might happen. Our model can be underfitted. That means that it doesn't predict the data very well. It's too generic for the data. That's our first example. Our model can be good, it can have a good fit, or it can be robust enough, so it's able to predict the data and predict the real data, not only test data as well. And there is a case when you can overfit your model. Overfitting means that you will your test data so tightly that it will give you a perfect result on your test data. But when you go to real life and when you get the values where you will need to build actual prediction, this model will not be as good as the good fit, the model in the middle, because it will be too specific, too narrow for your test data. And the best explanation of what overfitting is this. Right. So then before we move further, the last thing I wanted to talk about in the machine learning crash course is some dictionary. So those words you will see most likely no matter which framework you would be using, especially the first half. So label. If our data comes in tables, then the column we want to predict is called label, or we can say the feature that we want to predict, that is label. In the example of houses, the price for the house would be our label. Everything else, all other columns or all other features that we take into account when we are building our machine learning model, when we are training, these are called features. So in the house, it would be square footage, rooms, address, date of renovation, date of build, everything that we decide to take into account when we are building the model. These all are called features. Then transform or transformation. When we are getting data to train our model, we need to prepare this data in a certain way before our machine learning algorithm can use it. And the great example here would be some data comes in numbers and some data would be the text values. And our machine learning algorithm, the machine learning behind the scene, it all boils down to multiplying matrices. You cannot multiply number on a letter, right? So you need to represent the non-numeric data in numeric way. Another example would be if you're using some image recognition, you're dividing an image, you want that image to be the same size. So you want to resize those images so you have the same input. And the last term I wanted to touch base here is a trainer. So you probably all know what algorithm is, right, from the school, and now you know what machine learning task is. It's regression, classification, clustering, and so on. So algorithms can be applied for different tasks. For example, there is an algorithm called fast tree, and it can be used for regression, for binary classification, for ranking, and so on. So the algorithm plus the task, that's what we call trainer. All right, and with that, now let's move to machine learning framework for .NET developers called ML.NET. First, very briefly about ML.NET. That's a machine learning framework that allows you to build custom ML models. You can also use it for consumption of existing models, but it also allows you to build your own model, train it with your own data. And it is created for .NET developers, so you don't need to know Python or R or any other languages. You can stay in the .NET infrastructure that is familiar to you. It is already proven at scale. We released it in general admission in last year, and we released the preview in 2018. But before that, we had internal framework at Microsoft for over 10 years that was used for Azure development, Office, Windows Hello, SQL Server, and many other things. And just a few years ago, we decided to open source it and make it available for everyone. So that framework, even though it is young on papers, it is very mature. It is battle tested for many, many years on the big products. It is extensible, which means that if you have some team members that prefer to use TensorFlow or any machine learning framework that supports Onyx, you can take those models, export them in Onyx or TensorFlow format, and import them in ML.NET. So you can stay as a developer in .NET environment and consume the models that are written in other machine learning frameworks. And there is no need to write the glue code between Python and C# and so on. So it's extremely convenient for existing solutions as well. Of course, it's cross-platform and open source. It's free, it runs everywhere, and the repository receives a lot of attention, feedback. You can report issues, you can participate, contribute, be the developer of ML.NET. We really appreciate your feedback and your help with our open source community. And this custom ML, pretty hard task, is ML.NET made it easier with the variety of tools. And I want to talk more about tools. But before, another joke. You know the Pareto principle? So in data science, 80% of the time is spent on preparing the data, and 20% of the time is spent on complaining about the need to prepare the data. That is unfortunately very close to be true, because preparing data is a very hard task, right? You need to know how to transform in each column, how to present the data in the way that your machine learning algorithm can consume it, and that will be the optimal way of doing it. You need to make good calls on which data is more important, which data is less important, and so on. That definitely requires some data science knowledge, but luckily ML.NET has a variety of tooling that will help you to do this work for you. So ML.NET will use ML to do the data science work and come up with decisions for your problem. And there are two ways of how it can do it. There is an AutoML, which is the set of APIs that will make an machine learning intelligent decisions on how you want to build your ML model. And there is a model builder that is a visual extension to Visual Studio. So model builder uses AutoML APIs, and there are two different approaches depending on what you prefer. If you prefer code first experience, you can use AutoML. You can use AutoML via CLI or you can use Visual Studio Extension Model Builder. That one I will also show later. But right now, let's talk more about how this AutoML works. And let's take an example of taxi fare. So let's say we have a task to predict how much will be a taxi fare from address A to address B. So what would usually the data scientist do? Data scientist will define which features are important for our problem, like distance, trip time, car type, passenger, etc. Because, for example, the color of the car probably is not relevant, but the trip time and the distance have a huge effect on the price, right? Then data scientists will choose the algorithm that should be used for our problem. And you don't usually know which one. So you can guess few based on your experience, gut feel, but you still have to experiment because for different cases with different data, different algorithms give you better results. So to find the best model, you need to try different algorithms. And of course, each algorithm has its parameters, and you have to try the variety of parameters to find the optimal solution. So what data scientists would do, he would pick features, he would choose an algorithm and set parameters, and let's say we got a 30% result. So our model is only 30% accurate. Then the data scientist would do it all over again and get another option. And then they will repeat this task many, many times until they find the most satisfactory combination. So that is exactly what AutoML with ML.NET does. It accelerates model development for you. So it will intelligently try all possible options, detect which model gave the best results, and then suggest that model for your consumption. Let's go ahead and see how Model Builder works. I'm going to open my Visual Studio. And here I will create a completely new blank application. Console app. So you can see that I have zero code prepared. It's a blank console app, and I'm going to do right click, add machine learning. Excuse me, zoom in, right click, add machine learning. Here you would see Model Builder, and it starts with scenario. So you need to define what are you trying to do. And there are a few examples to help you start with. So, for example, test classification or value prediction, image classification, recommendation, then anomaly detection, forecasting, clustering, object detection, and so on. So you can pick from one of those. And here I wanted to show you that for image classification, we have few options to train it on your local machine or to train it in Azure. So that's the first scenario where we enable training in Azure. So when you need huge capacities, and for image classification, you have this option. And we're planning to bring that Azure option to other scenarios as well. So in our case, we want to predict the price for a taxi fare. So we're gonna choose value prediction. And it tells me that the training available on my local machine. I proceed to data. So here I can choose to upload my data from a file or from SQL Server. I have it on the file, so I specify the path to my file. And now I need to tell my ML.NET what am I looking for, what am I trying to predict. I need to set the label. So in our case, label will be fair amount. Oh, and as you can see, this is the preview of my data. So I have vendor ID, rate code. Rate code, it's is it the rush hour or is it the normal hour? Depending on the rate code, prices go higher or lower. Number of passengers, trip time in seconds, trip distance, and the payment type, either it's a credit card or cash. All right, and here I also need to specify which columns I want to take in account when I build and train my model. So here I can check and uncheck, and if you see, for example, a color of the car and you suspect that probably won't be very relevant, you shouldn't check that. In my case, I'm gonna keep it the way it is, and I'm gonna go to train. And here I can set up the time that I want to train my model for. And usually the longer you train, the better, but there is an extremely useful link. How long should I train for? Let me show you. And it takes you to this table where, depending on your data size, it suggests you the optimal time to train. And my data is only 3 megabytes, so test seconds is more than enough. And that is the mistake some people make. They think, okay, I want my model to be really good, so I'm going to set it for 24 hours. No, in my case, 10 seconds is perfect. I'm going to start training. And here in the output window, I can already see what is happening. So these are different algorithms that AutoML is trying for my data. And for each algorithm, it calculates a bunch of metrics that help to make a call on how successful this particular algorithm was. And perfect. We have a summary. So we have task regression. This is my trained data. This is the labeled fare amount. And it took us almost 10 seconds. We explored 13 different models. Go here. And this is our winner. Best model is LightGBM regression. That is the algorithm. And the best quality R-square is 0.94, which is great. The closer it is to 0, the better it is. Now we can evaluate. And here, the tool already picked one line from my test data, inserted it, but I can also try on any other data. You can click predict, and it will give you the prediction. So it already used that model to predict the price. So here you can play, you can set different values and see what will be the predicted value for the price. Now we can go to the code and click Add Projects. So what just happened, Model Builder added 2 projects in my solution. And those projects have the same name as my main project, .console app and .model builder. So let's take a look. .model. In model, we have model input class that describes our incoming data. So we have vendor ID, rate code, passenger count, trip time, etc. That's all columns from my data. We have model output, which has a score. And the score, that's our reserved name. Usually the value we're looking for, it will come back as a score. We also have this model, ML model.zip. This is our model. That's a ML.NET model. And once we train it, it will be saved in a zip file, and then we can just upload this zip file and use it for consumption. Right. And let's take a look at the console application. So let's open program.cs. Here you can see it already created a sample that we can try. It created the model input. It populated it with the first row of my data. And then it called consume model.predict on this sample data that it created for us. And then it just prints out the result that it receives from consume model predict. let's go here, and in consume model.predict, you can see we are creating prediction engine. It's lazy initialized. Let's go here. So for predict engine, we are creating ML context. We are specifying the path to our zip model. Then we load the model from that path, and we are creating prediction engine based on that model. On that prediction engine, we call predict and send the data. So this is the code for consumption. Once we already have the model trained and saved in the zip file, then in your .NET application, this is all you need. You just upload the model and you create prediction engine, you call prediction engine, don't predict, and you're free to use it. These calls are very fast compared to training, and that's how you will use the model in production. So let's set the console app as a start project, and let's run it. All right, so this is again to show how we are using our model that got trained by ML Builder, and it basically loads the model, takes the role, predicts the price for it. Now let's look at what else we have here. And here we have another class, model builder. And in this model builder, we have a code for actually creating and training the model. This task you need to do once, or you can do recurring, like every month you want to retrain it with new data, but that usually is done once to get the model, that ML model zip file that then you can use in your applications. And before we take a look in this code, let's go back to slides and let's talk about what are parts of the training our model. So creating the model contains 4 different steps. First, you are building this model, then you're training it, then you're evaluating how good this model is. And if it's good enough, then you go ahead and you use it, and that's the part of the code that we just saw. And if you're not satisfied with the quality of your model, then you go all the way back, change something here, train it again, evaluate again, and continue this cycle until you get the good results that you can use. And each of those steps also involves certain actions. So for building, you need to upload the data into your machine learning model creation program. Then you need to prepare the data. That's when we talked about transformation, that you need to present the data in the optimal form that machine learning algorithm can consume. And then you choose algorithm. And we have the variety of algorithms on this link, and I will also have all the links at the end, so don't worry, I will show you the slide with all links you need. So here, for preparing your data and choosing algorithm in ML.NET, it is done via built-in training pipeline. The training pipeline is a concept, you can think of it as a graph where we specify every operation that we need to do on the data and every algorithm we want to use. We build it as a pipeline. This pipeline also knows about the data we're going to train on and so on. We will take a closer look when we will be looking at the code. Okay, next step, train. It's just running the choosing algorithm on the data that we provided. And when we want to evaluate our model, we want to make call how good or how not good our model is. That's when we calculate a bunch of metrics that show us how good this model does on the test data. So for training, we reserve some chunk of data, and we usually call it train data. And then we want, when our model is trained, we want to make a call, is this model good or bad? We show this model a new set of data. That set of data we call test data. And if the model is not good, we go back to build phase and repeat. Once our model is good enough, we can go ahead and consume. So let's go back to Visual Studio. And here you can see the same steps: load data, build training pipelines, train model, and so on. So on loading data, we are calling ML context data load from file. We specify the type of our data, model input that we looked before, and we provide the path, and we specify some parameters like, is there a header? What is a separator? Is it comma or tabs, or etc.? Then we are building our training pipeline. And here, let's go ahead inside. This might get a little bit confusing, but luckily this code is already produced for you by a model builder. So first you can just run it, you can get an example, and then you can build your way into that. So we're calling on ML context transform. This line, what it does, it transforms our non-numeric data into numeric data. Let's go back to model builder. Here on the data, remember we have vendor ID and payment type. These are letters instead of numbers, right? So we need to first transform them into a numeric vector. That's what we do. We do it with the help of the algorithm called one-hot encoding. So transforms categorical one-hot encoding, and we specify the columns we want to one-hot encode. So translate into numeric vectors. It's vendor ID and payment type. Okay. Then we are appending all the rest of the columns, and we call them all features, because all the columns that we feed in as input to our algorithm to be trained, that we call features. So it's vendor ID, payment type, rate, passenger, everything else goes here. Now we choose algorithm. And remember that regression is our task. We are trying to predict the taxi fare value, so we choose regression, trainer, and this is light GBM. So remember, when model builder run a bunch of different trainers, different algorithms, it detected that light GBM was the best solution for us. So here we are using light GBM, and we specify what we want to predict. That's our label, fare amount, and what we are using for that prediction. That's features that we created on the line before. And we are adding trainer that we just created. So you can think of trainer as an algorithm. It's algorithm for regression task. We're appending the trainer, and we are returning the training pipeline. All right, so we built training pipeline, and now we simply train it. And the way we train it, the training pipeline dot fit, and provide the data we want to train or fit. Once our model is trained, we want to evaluate this model. And for that, we are choosing, so first we are specifying cross-validation. And the cross-validation, remember when I told you that we should use one set of data for training and another set of data for validation, for testing how good our model is. But you provide only one set of data, ML.NET can do the separation for you. That process is called cross-validation, and it does even more. So when we specify number of folds here, 5, that means that the data that comes in, our taxifair data, it will be divided into 5 chunks. And then the algorithm will hide one set and train the model on the rest 4. And then it will evaluate the model on the set that was hidden. Then it will take another set and train the model on the remaining sets and evaluate on that one. And it will repeat that 5 times. Then it will get the aggregated result for all 5 cases. So this is what this line does, and it's called cross-validation. And the print regression false average, that's just printing everything on the console. Sorry. And once we evaluated our model, the last step, we are saving model on the disk. And we just do ml context model save, specify the input model input schema model and the path. And that is basically it. So now I would suggest we are gonna, instead of just consuming our model, what we did here before, we can delete this one. Now we don't have any model, and we will train and evaluate it from the code. So when I call this, we will go to the code we just looked at, and we will upload the data, we will create the train pipeline, we will train our model, we will evaluate the model, and we will save it to the disk. Then we should be able to get the sample data and run the model and get the prediction. And to make it interesting, let's take some sample data. So here is my file with the data set that I haven't shown to my model at all. It's completely different. It's taxifair test. And there is a 1000 number. So it's 933 for me. Let's get the 933rd item and try to predict the value. All right. So let me insert those values real quick. Vendor ID. Yeah, then 1, 1. This is our time. 3, 4 is the distance. And this is the actual value, $13. Let me insert this one right here. And say actual. Actual fair amount is $13.50. All right. Let's run it, and we are gonna build the model, train it, save the model, and predict. Here you can see process. All right, so this is our data, and predicted fair amount is 13.1 and actual fair amount is 13.5. So that is a very nice result, I would say. go back to the slides, and that is basically it for today. This is the link with, this is a slide with all links, so you can get started with ML.NET today at the .NET/ML. And we have lots of samples, so you can start with looking at existing solutions. They're getting started and end-to-end projects. You can read the docs. You can be a contributor at our repo because it's open source project. So please go ahead, report issues and feature requests, participate in creating the ML.NET with us. We really welcome your feedback and your help. And there are also the docs chapters that I mentioned in the slides before. So different machine learning tasks, you can find them there, different machine learning algorithms, ML metrics, and basically any question you will have with related to ML.NET, you can find it on docs. And with that, thank you very much for your time. Now let me see if there are any questions. We probably have 3 minutes left.